Question 4 is about thin film interference, and initially asks us about the phase changes that might occur at these two boundaries that we've got. So we've got air to a refractive index of 1.3, then 1.53. So light is going from less dense to middle density to even higher density. If we have a look, it's asking us to state the phase change which occurs to light that is transmitted at boundary A, so that's between air and this initial one. Well, when we've got less dense to more dense in terms of refraction, there is not going to be a change at all, so there's zero phase change. However, for part 2, it's asking for the reflection, so light which is reflected off of this boundary. When we've got a reflection of less dense to more, boundary of less dense to more dense, we get a pi change, or a lambda over 2 phase change. Part 3 then asks, what about from going from the thin film back into the air, so from here to here? Well, again, that's going to be a phase change of 0. Part B asks us to find out what the smallest thickness, T, of the coating is required so that the reflection is minimized. If we want a minimized reflection, we're looking for destructive interference to take place. If we go back up to have a look at this, so we've got light that is initially just reflected straight back, or there's some light which is going in and then being reflected back. There is a pi change both here and here, which means that they sort of cancel each other out. They're going to both have the same effect on each beam of light, if you like, which means that we need the thickness, or the total path difference here, to be equal to the condition for destructive interference. So what we're saying there is that we need 2nt to be equal to lambda over 2. It's 2nt because the lights have to travel both there and back, and we want that to be equal to the condition for destructive interference, which is that path difference is equal to lambda over 2. So we're asked to find the smallest thickness, so therefore we want n to be equal to 1. If we rearrange that in order to get t, it should come out as t being 110 times 10 to the minus 9 meters.